Okay, here's another fun thing you can do with LEDs, and that's create an LED binary clock. So the way binary works is um, the number 0 is, we'll do a 4-bit binary clock. So it's all zeros, kind of makes sense. Then what happens is you have the number 1. And to get the number 1, it looks like the number 1. So each one of these bits, it can only hold the numbers 0 or 1. And we want to have those turn into numbers that we're used to seeing. So the way that this works is we're going to use certain columns here. The first column denotes the number 1. It's either a 0 or a 1. The next column is 2. The third column is 4, and the fourth column is 8. The reason for that is this first column is 2 to the 0 power, or 2 to the 1 power, which can hold the numbers 0 and 1. This column, the second column is 2 to the first. 2 to the third column is 2 squared, which is 4. The fourth column is 2 to the third, which is 8. 2 times 2 is 4. 4 times 2 is 8. And so the next column would denote 16 and 32 and 64. So that keeps going. And that allows us to actually get all of the numbers, but just using zeros and ones. So let's keep going through this. So 0 and 2, the way that one works is here we have a column that means 2, okay? So we get a 1 in that column, and then a 0 in the 1 column. Here's where it starts to get a little bit interesting. 3 is 2 plus 1. So we need a 1 in both of these columns, and 0s in the other ones. So 0, 0, 1, 1. 4 is... Again, we have a column 4, 4, so that's going to be the only column that gets the 1. 5 is 4 plus 1, so those two columns get the 1s, 0, 1, 0, 1. 6 is 4, so in the 4 column we get a 1, and the 2 column we get a 1. And then 7 is 4 plus 2 plus 1. 4, 5, 6, and then 1 more is 7. Then 8, again, we get 1 column for the 8, and everything else is 0. 9 is 8 plus 1, right? 10 is going to be 8 plus 2, so a 1 in the 2 column. 11 is going to be 8 plus 2 plus 1. 12 is 8 plus 4. 13 is 8 plus 4, not plus 2, but plus 1. And 14, 1, 1, 0, 1, 1, 1, 0. 15 is 8 plus 4 plus 2 plus 1. And at that point, we don't have any more bits. So the having 4 bits only allows us to get the numbers 0 through 15. But that's what we're going to play with today. We're going to see if we can make a 4-bit LED clock. So to set up the schematic, this is what we're kind of going for. The third pin from the back is a ground pin. So this is a GND. And then the 4 pins after that are pins 18, 19, 20, and 21. And we're going to plug those up in this way. So you can just kind of look at one of these. We've got the wire coming from the pin to the resistor, then the resistor hooking up to the positive side of the LED. And then on the negative side of the LED, we're going to go back to ground. So let's work on that. So we'll disconnect that. So first what I'm going to do is I'm going to take this black wire here and move it so that it goes to the negative kind of ground line. So again, these two breadboard lines run all the way in a row, whereas all of these other ones run in a column. So this will just make it a little bit easier to connect the other LEDs up to the ground, because I'll just have to plug them into that negative line there. And then we'll have 4 wires coming off of the next 4 pins. More red wires. And again, you could use, yellow. Actually, why don't we do that? We'll use yellow for the next one. It's a longer one, but a blue. And now we're choosing the yellow. All right. And then we need 4 resistors. Remember, every LED needs a resistor. So we've got one on the breadboard now, and then 3 more. And again, we can kind of wire these up however we want. We just need to make sure that our resistors are kind of going into the positive side. So if I pull that back out again, you can see that our longer wire is going into the side that the resistor is. And then our lead is going to go into the same column as the other end of the resistor. And then off of the negative side of the LED, which is going to be this column here, I can just put a wire here wherever it's easiest to fit one in and connect that up to the negative side. And then we'll just do that 3 more times. All right. Now you can make these kind of as compact as you can try to get away with. Just make sure the wires don't touch. The wires don't always have to be in exactly the same spot. You just don't want them in the same column. All right. So then we grab the yellow one for our next input. The input's going to go into the same, into the left-hand side of the resistor. And then our next LED. 2, 3, 4. So our next LED. These I will put in the same kind of row just so that they can look better. And then we have another black going back to the ground off of the negative line. This is where breadboards can be fun, but they can also get kind of messy. One thing that could make this a little bit easier is to actually put these resistors at an angle, so that they still are only in 2 columns, but don't take up as much room and have less chance of touching each other. That's why I stagger these, actually, because the resistors can easily touch each other, and you'll get a short and some weird solutions. So then here's my next LED. Positive side on the right. Blue will go to the resistor. And then the black one go from the negative side to the ground. And then one more resistor where you can stick it in, put it in. And LED. I guess it's an orange wire. Go into the resistor. Make sure we don't have any issues there. And then one more ground wire on the output side or the negative side of the LED going to the ground. All right. So if we plug this in, hopefully nothing should happen in this case because we don't have any outputs going to any of our LEDs. All right. They have a good way to position that now. Again, too many things going on. Okay. So now we will go to Visual Studio Code and we'll talk about what we need to do. So we're not using LED 26 anymore. We're going to use 18. We'll look back at our pinouts. 18, 19, 20, and 21. That came through that blurry. So we'll use 18. So I'm going to call 18, as it's the far right pin, I'm going to associate that with the number 1. So I'm actually going to call these LED 1. And we're going to get rid of LED. We're not going to use the LED, the onboard LED anymore. All right, so then we need another LED. This is going to be for the holding up to the number 2. And that's going to be GPIO 19. And then we'll need 2 more of those. So then the next one's going to be 4. And that's GPIO 20. And then LED 8. Pin 21. So I'm keeping the LED numbers. You can name them whatever you want. They're just variables. But I can take the numbers and make them associated with the number from what we were looking at here, the 1, 2, 4, 8. Just makes it make sense a little bit more in my head. All right. So, yeah, we don't really need to print anything. So while true, we'll have our count equals 0. That's what number we're on. And I'm going to say count equals, I'm going to put in parentheses, so it's going to do this first, count plus 1. It's going to add to it. But then I'm going to do the modulus and mod it by 16. So that will give us the numbers 0 through 15. At the number 16, it'll divide it by 16 and take the remainder, which is going to be 0, and that'll set us back to the number 0. So I do actually want to print, we'll convert it to a string, the count variable. And so now this will print out what number we're on. And we will sleep 1 time here at the end. All right. So just to check this, and we'll make this only sleep for half a second. So let's save that. And if we connect to our COM port, okay, so we're counting up 15 back down to 0. So that's what we want there. Now what I want to do a quick check and make sure I've wired this up okay. I'm going to say LED1.value equals true. And if we save that, we should get our 1. And then we'll change it to 2 and we'll save it. So 2's on. Set 4 to true. 4 is on. And then 8. 8. Okay, so we at least know we wired things up correctly. That's really helpful. So now what we will do is we'll start doing our actual coding of turning the LEDs on and off again. So one way to do this is we can say LED1.value equals 0. And then LED2.value equals 0. LED4.value equals 0. And LED8.value equals 0. So this would be all zeros. And the sleep there. And that's going to be our number 0. Okay, and then we can do paste. And here we can set that to 1. Now we've got the number 1. And we can paste these in a few times. Right? And then if we want to do 2, we set the 2 value to 1. And if we want to do 3, we have to set, not to 2, we have to set 2 and 1 to 1. And so we can just kind of keep coming down. And so let's see, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we have a whole bunch of numbers here. So 0, 1, 2, 3. So now when we want to do 4, that's going to be a 0, 0, 1. 5 is 4 plus 1. 6 is 4 plus 2. That's why I named the LEDs the way I did. So now we can see 4 plus 2 plus 1, that's 7. So then 8 is like that. 9 is going to be 8 plus 1. 10 is going to be 8 plus 2. So see, binary is really not hard. It's just adding. 8 plus 2 plus 1 is 11. 8 plus 4 is 12. 8 plus 4 plus 1 is 13. 8 plus 4 plus 2 is 14. And then 15 is everything ones. So if we save this, now we should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and back to 0. So that's how it works. Now the weird thing is we're not actually using our count value. And so, and we also have a whole bunch of code. Let's say we messed one of these up. And so we actually did 8 twice. And you save this and you go 1, 2, 3, 4, 5, 6, 7, 8. Wait, it did 8 twice. We didn't get an 8 and a 1. So that's wrong. Well, then you have to go through and figure out which one of these is messed up. So what I actually want to do is show you how to create a function. Now, functions can make your code a lot cleaner because you can do you can reuse the code and compartmentalize it a little bit more easily. So let's do set LEDs, and we've got LED L1, L2, L4, and L8. I guess we do V for value. And actually, I'm going to change these. I'm going to keep these in the way that the binary bits are going to be, right? So it's bit, the farthest left bit is 8, and then the farthest right bit is 1. Now, we've defined a function, and so we have to put a colon at the end of it. And so then here we can do LED1.value equals V1. LED2.value equals V2, LED4.value equals V4, and LED8.value equals V8. Now, all of this makes it, and we can even put our time.sleep 0.5, so that's all in one place. So all of this is going to turn into set LEDs 0, 0, 0, 0. That's it. So now we can get rid of all of this one. And then the next one is set LEDs, and we want to set it to 1. And that gets rid of all of this. And then the next one, we want it to be 2. That's that. So now we can go through, we can take all these hundreds of lines of code and compress it way down into a much more manageable don't know why I keep doing it that way. Let's grab 0. So then 1, 1, 1 on there. Nope, not an exclamation mark, but a 1. And then 1, 1, 1. Now here's the other thing. So we got 0, 1, 2, 3, 4, 5, 6, 7. And then it kind of like starts over again where we get a 1 here, but then the rest of the columns all look like this. So we can actually grab these, copy them, and paste them. And then we can do that selection, column selection mode. We can select this whole column, press the number 1 once, and now we have 8 plus those values. So we've got 8 plus 0 is 8, plus 1 is 9, plus 2 is 10, plus 3 is 11. So we really quickly got to our, turn that off again. We got back to our code really easily. So we went from 120 or 30 lines of code down to 50. And it's a whole lot easier to read it. We can see exactly what the binary bits are. So if we save this now, it looks just the same. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, or 15, and then back to 0. Okay, so functions make this a whole lot easier to see this and a lot easier to understand. Here is one last way to do it without doing any kind of functions and where we'll actually use our counter. So we're actually not even using this count value right now. We're just hard coding the LEDs to the actual values. And the thing I wanted to do was show you a little bit of a more advanced kind of math way to do this using something called bits and bit masking. So the way that bit masks work is, here's some code that I put together. And it actually had 5 bits. Nah, sorry, I undid that. So what we're going to do is we're going to do bit masking. I'm going to set this one to false. I don't want to actually use that code now. While true. So here we're going to grab our, because we didn't need the count up there either. And we'll take our count value and yank it down here. Okay. So here's our version of this code that's going to use count. And the way that this works is you'll say, we can grab one of these. So for the LED 1, what this is going to do is it's going to say, okay, the value for LED is true or 1. Either one of those, actually, you can see here, we passed the number 1 and that set it to high, or you can set it to true. But we can set it to 1 if count, which is our number that we're on, and then a hex number. So the hex is kind of like binary, kind of like decimal. It's kind of another way to think about numbers. In this case, because we're dealing with smaller numbers, 1, 2, 4, and 8 are actually going to be the numbers 1, 2, 4, and 8 in hex. We might talk about hex in class sometime, but for now we'll just run with that. So then LED 2 is going to be, if it and 2 is, then it'll make it 1, and then 4, and we bit mask that with 4, and then 8, and we bit mask it with 8. So what I mean by bit masking is if we look at the numbers 001, 0010, 01, and okay, so this is the number 1, this is the number 2, this is the number 4, and this is the number 8. Okay, so if we were to take some random number let's say 1010, okay? And we bit mask those. What you're doing is that one by one, the code is saying, put this over here. What the code is saying is that if the current count value that we're on, if you bit mask that with the number 1, and those two numbers both have a 1 in that column, then set this LED to true or 1. Similarly with LED 2, if the bit mask for 2, which has a 1 in this third column, also, if our number has a 1 in that third column, then that's a true if. So then it'll make that LED 1, otherwise it'll make it 0. And then same thing with 4, that's that second column. So when looking at this, LED 1 with it bit masks, when we're on this number, which is 8, 9, 10, is going to get us a false for the 1-bit mask, a true for the 2-bit mask, a false for the 4-bit map, and a true for the 8-bit mask. So then that would turn those LEDs on or off based on the bit masking. And then again, at the end of the loop, we flip back around to 0. So if we save this, okay, it's actually happening really quickly because I took out the time.sleep. So let's put that back in again and save that. And now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then back to 0. But this is all of the code that's running. This is where programming can be fun because you can take your code from taking hundreds of, 150 lines of code by doing a whole bunch of copy and pasting, but it's really hard to manage. And if you kind of know what you're doing, over time, you can get your code so it's much more concise, easier to manage, and in the end, actually executes faster. Even though, in the grand scheme of things, this is not a speed type program. But this is just kind of a slick way to do it. This is the much more common way, probably, that you would see to do it with a function where you can easily see what binary number you're setting it to. We could pull this into a function if we really wanted to, but there's not really a reason to because this is, we're not doing this over and over again. We do this once, so then the function would just be called once, and it wouldn't really get us a whole lot of benefit. Yeah, so I hope that's helpful. I hope some of you try doing the binary clock. It's kind of a fun little way to look at numbers or think about numbers. There are people that actually make full clocks that go up on a wall that are all in binary. And if you don't know what you're looking at, they're really hard to read. If you do know what you're looking at, they sometimes can still be really hard to read. And again, I'll show the printing diagram for that. It's just the third pin going to ground, or third from the bottom on the right-hand side going to ground, and then the next 4 pins going towards the USB port are your 18, 19, 20, and 21. Actually, that is in the wrong spot. That should go there. Yeah, so give that a try. See if you can do it, and look forward to seeing if you guys figure something out.